Welcome to Tech Teach.
So in the previous classes, we have gone through the gate level minimization by using K-map. The next method that we will be looking is the QM tabular method. So this QM tabular method. So here QM stands for Quine-McCluskey method. Okay, so Quine-McCluskey, that is QM tabular method. So that is the second method for the gate level minimization. The first method we have already seen, the K-map method for different variables. So if the variables are 6 or less than 6, we will be using K-map. Otherwise, we will be using the tabular method, that is Quine-McCluskey tabular method. Okay, so we will just see like what is this tabular method and how it basically works. So we will be looking with the help of a few examples. Before that, we will just go with the theory part, like how it basically describes the tabular method. So basically, this method depends on the theorem called complementation method or complementation theorem. So it depends on complementation theorem. So what is complementation theorem? So basically, the complementation theorem says that if x dot y plus x dot y bar is there, we will be adding these two terms. It will be resulting into x. So how it is resulting x? Because if we take x common, y plus y bar is equals to 1. So 1 multiplied by x is equals to x. So two terms are there. This is one term and this is second term. Both are added such that one of the term is multiplied with the variable and the same term or the second term, one x is another term that is multiplied by the complement of the variable. So y bar is there. So yes, so this complemented form of a variable is there and other part is same. In that case, we will be combining it together and then we will be able to reduce that particular variable. So here y variable is reduced to only x. Only x is available. So this is basically called the complementation theorem. So here the x can be either a variable, x can be a variable, or it can be a term. Term in the sense it can be having a group of variables, like x can be AB or x can be BC likewise. So it will be a term. X can be a term also, or x can be an expression. So an expression can be there as x. So in place of x, we can have an expression also. Means instead of AB only, it will be AB plus BC. It can be there. X can be it. So x can be a simple variable x only, or it can be a term, or it can be a expression. But here y will always be a variable. The same thing we will be verifying by using the example, so it will be clear like how it is basically uh, being used, complementation theorem. So here, once we will be finding it out, so whatever is the function, so if a function is given that is having few main terms, okay, so it is like AB plus BC plus AB bar plus BC bar. If suppose this is the term, then we need to find out the terms. We will be grouping the terms such that one variable is complement in two different terms. One variable is complemented. Okay, so here B is there and here B bar is there, and A is common to both of them. So we can combine or we can group it together. Similarly, this can be grouped it together so that we can minimize the C here, and here we can minimize the B. B can be minimized, here C can be minimized. So likewise, we will be making the grouping. So after going for the mean terms, we will be grouping it together. After grouping, we will be minimizing it by using the complementation theorem. So what are the different steps? We will just write it down, like what are the steps for solving the questions related to QM tabular method. So the first step is we need to write the expressions into canonical form. So canonical form is required. So in K-map also we have seen whenever we are proceeding for K-map, we should be writing the function into the canonical form. So that is one of the requirements. The first step we will be doing. Second step is now we will be grouping the terms. So here this terms is mean term and max term. So grouping the terms based on the number of ones. So number of ones in the sense, so suppose these are the mean terms. So these are the mean terms A B B C A B C, like three into, we will be converting it into canonical form first of all. So after converting it into canonical form, it will be coming out like what are the mean terms. So suppose in canonical form it is A B C, A B C bar is there. So A B C is equivalent to 1 1 1. A B C bar is 1 1 0. So this is like suppose a term is there A bar B bar C. So it is 0 0 1. So number of ones is 1 only. Or suppose it is A bar B bar C bar. This term is there into the midterm, so it will be 0 0 0. So number of ones is 0. So based on the number of ones, we will be doing the grouping. So that is the second step. Third step is by doing the grouping of the mean terms. Now we will be comparing one term of one group with terms of other group. Okay. So now we need to create a new table by comparing terms of one group to terms of other group one by one. So basically we are going to create another table by combining the mean terms from one group to the mean terms of other group. And while comparing, we will be comparing basically the number of digits. Okay. So if we will be making the pair or grouping will be done if only one bit or one variable change is there in between the terms. If after comparing two terms from two different groups, if only one bit is changing, then we will be doing the grouping. If more than one bit is changing, no need to do the grouping. So whatever I'm saying, it may not be uh, you may not be able to understand it properly, but once we will be looking at the numericals, you will be getting everything. So don't be worried about the terms that we are explaining here. Okay. So once we are on the grouping will be done with respect to only one bit change. And where is the change? So we will be place dash place dash at bits that do not match. That means if we are doing the comparing, and if three bits are there, three bits from here, three bits from here, you can just see. If you do the comparing, one is matching, but the last bit is not with matching. So one bit change is there. So whatever is the change, we will be after comparing, we will be writing like it is one one, and at this position it is zero, and at this position it is one. So one bit change is there. So grouping of these two terms will be there and taking place. And at this position we will be placing dash. So dash will be placed where there is a change in bit. So that is what is being explained. And the same thing will be repeated. Now repeat step 3 and 4 for terms of next step. Till all possible groupings are done. Okay. Then at last, whatever terms are left, will provide the minimized expression for the function. So whatever I am telling, we will be just looking with an example like how it basically works. So once we will be taking an example, it may be more clear to you. Okay. So for taking an example, we will be taking an example with respect to two different cases. One is like sum of product cases. So if a function is there defined by like the sum of product function. The sum of product in the sense it is defined by the four variables. In that it is written a bar b, a bar bc plus a bar b bar d plus a c bar d plus b c bar d bar plus a bar b c bar d. Suppose this is the function. Now we need to go for the solution by using the QM method. So this expression is in SOP format, sum of product, but it is not in canonical form. So first step is to convert it into canonical form. So for converting it into canonical form, we have to add the missing variable part here. So A, B, C is there, D is missing because it is four variable case is there. So here D is missing, so we will be placing it like A bar B C. Instead of D, we will be placing D plus D bar. Here C is missing, so it will be A bar B bar C plus C bar D. Here B is missing, so it will be A B plus B bar C bar D. Here A is missing, so A plus A bar B C bar D bar plus A bar B C bar D. So here four variables are there, so no need to change. So now we need to expand it here. So after expanding, we will be getting like A bar B C D plus A bar B C D bar plus A bar B bar C D plus A bar B bar C bar D plus A B C bar D plus A B bar C bar D plus A B C bar D bar A bar B C bar D bar and then A bar B C bar D. And this is the case. Okay, so after writing it into canonical form, this is the case. Now we need to just write it down like what are these mean terms. So for that, you can just see here it is A bar is there, so that means it is 0 1 1 1. So 0 1 1 means it is 7. So this indicates the mean term 7. Similarly, this indicates, second term indicates the mean term, that is 6. This indicates the 6. Similarly, this indicates the 3. This term indicates 1. This indicates 13. This indicates 9. This indicates 12. This indicates 4. This indicates 5. So the mean terms we can write in here. So it is M1, M3 is there, M4 is there, M5 is there, M6, M7, M9, M12, M30. So 1 is there, so 1 can be represented by 001. 3 is there, so 0010. 4 is 0100. 5 is 0101. 6 is 0110. 7 is 0111. 9 is 1001. 12 is 1100. 13 is 1101. So this is how the mean terms are there, that is available into the function. Now we need to do the second step, that is grouping. So we need to do the grouping. So once we will be doing the grouping, that will be creating a table. So we will be calling like there is a table, that is table 1. So into that table 1, we will be creating the groups A, B, C, D is there. So what is the A, B, C, D values? And now the grouping will be such that we will be finding it out, the groups, based on the number of ones into the mean terms. So starting with M1, it is having 1. So 0 mean term is not available, like 0 number of ones is not available, minimum number of 1 is 1. So M1 we will be taking, so it is number of ones is 1 here. M3 is also having 1. M4 is having 1. And yes, so these 3 are having number of ones as 1. So based on the number of ones, we will be doing the grouping. So the first term will be M1. So M1 is having 0001. Number of ones is 1. Now M3. So sorry, M3 is not there. M3 should be here. Likewise, M3 is 1 1. So M3 will not be coming under the number of ones is not 1. It is 2 is there. So number of 1 is into M4. So we will be grouping it. M4 will be 0100. Next, then no further term is there that is having number of ones as 1. All others are having more than 1 number of ones. So this is group 1 now. This will be called the group 1. This is group 1. Similarly, we will be making the next group. So next group we will be having number of ones as 2. So here M3 is having the 2 number of ones. 0011. Number of ones is 2. Similarly 4 has been done. So here we will be checking it out. So M1 has been done, M3 has been done, M4 has been done. M5 is also having 2, so it will be M5. So 0101. M5 is there, it is done. M6 is also having 2 number of ones. So M6 is 0110. M7 is 3. M9 is having 2. So we will be writing down M9 is 1001. M12 is also having 2. So M12 is having 1100. Okay, so that much of the term are having 2 number of ones. So this will be coming under the group 2. So this is the group 2. Next is group 3, that will be having 3 number of ones. So 3 number of ones is having M7. So M7 is having 011111. Yes. So M7 is done. Next is M13 is having 3. So M13 1 1 0 1, three number of ones. So this is the group 3. So this is how the table 1 is created. So after table 1 we will be going for table 2. So into the table 2 again we will be considering the A, B, C, D values, but after grouping. So how the grouping will be done? We will be doing the grouping based on the comparison. So now we will be comparing M1 term with M3, means each of the term of group 1 will be compared with each of the term of group 2. Similarly, each of the group 2 terms will be compared with group 3, and we will be checking whether a pairing can be done or not. So whether a pairing will be done or not, that depends on the change in number of digits. If change in number of digits is only 1, then only we can make the pairing. So you can just check it here. So if we are comparing M1 with M3, so if we compare it here, so it is 0 0 0 0 0 1. So 0 1 means one change is there. Similarly 1 and 1, so it is same. So between M1 and M3 only one bit is changing, that is this one. If only this bit is changing, that means it can be paired. So how it will be paired? It will be paired like it is 1 comma 3, we can pair it. So mid term 1 and 3 can be paired or grouped together. It is grouped together, and then its values will be written. So its values will be written such that whatever is the common that is not changing, that will be written as it is. So 0 0 and then 1 is as it is, but where the bits are changing, that will be written as dash. We'll writing it as a dash. I hope it is clear to everyone. Yeah, so the next we will be checking M1, we will be checked for M5. So once we are comparing M1 with M5, you can just see this is 0, this is 0, same 0, and this is 1. There is a change. So here there is a change. If there is a change, only one change is there. Next is 0 and 0, same is there. 1 and 1, same is there. So only one bit is changing. That means we can do the pairing. So 1 will be paired with 5. And what will be its value? So whatever is not changing, it will be written as it is. So 0 0 is not changing, so it will be written 0. 0 and 1, one change is there, so dash will be written. Otherwise 0 and 1 are not changing, so 0 and 1 will be written. So likewise we need to compare for all other terms. So M1 will be compared with M6. So here it is 0 0 1 0 1 0. So 2-bit change is there. So if 2-bit change is there, then we will not be making the pairing. So one more thing, while doing the pairing, suppose M1 is checked with M3 and it is being only one bit is changed, and we are doing the pairing. We are grouping it together. So once we are grouping it together, we will be making a tick mark. So M1 has been paired with M3. So if any of the min term is paired with any of the min term, then we will be making a tick mark. If it is not paired and all combinations have been completed, then we will be making it star. Okay. So M1 is compared with M3, it is ticked because it is paired. M1 is compared with here, it is also paired because of only one bit change, so we will be taking it out. M6, more than one bit is changing, so we will not be taking it out. M1 compared with M9, it is just, you can look, yeah, only this one bit is changing, so we will be doing the pairing and then we will be taking it out. It is 1 will be paired with 9, and the values will be like dash because first bit was changing, and then 0 0 1 0 0 1. Similarly, M1 will be compared with M12. Here more than one bits are changing, so we will not be making the grouping. Next, we will be checking M4 with all other terms of group 2. So M4 will be checked with M3 again. So M4 with M3. So here same, this is different, this is different, this is different. So more than one bit is different, so pairing will not be there. M4 will be paired with M5 and compared with M5. So it is 0 and 0. It is same, this is same, this is same, last bit is changing. So only one bit is changing, so it will be pairing will be taking place. So 4 will be paired with 5. So once the 4 is paired with 5, 5 is already ticked, so we will be taking it out. 4 also. So once we do the comparing, this is 0 1, sorry, 0 1 0, and last bit is changing. So 0 1 0 dash. M4 will be compared with M6, and again here only one bit is changing, so we will be taking it out, and 4 will be grouped together with 6. So once the 4 is grouped together with 6, it is 0, then 1, then dash, and 0. So 0 1 dash 0. Now M4 will be compared with M9, so it is 1 bit change, 2 bit change, so more than 1 bit change is there, so no pairing will be taking place. M4 will be compared with M12, so you can just see, yes, only 1 bit change is there, that is the first bit. Okay, so M4 will be paired with M12, and at the first bit it is having the change, otherwise it is 1 0 0. So now all possible terms of group 1 is compared with group 2. Yeah, M12 is paired, so it will be ticked. So all the possibles between comparison between group 1 terms with group 2 terms we have done. Then we will be proceeding to compare group 2 terms with group 3 terms. So till now that is comparison between group 1 and 2. So now whatever the grouping has been done, this will be considered as now a group 1. Okay. Next we will be doing is comparison now M3 with M7. So M3 and M7 we will be comparing, it is 0, same, this is different, this is same, same. So we will be pairing 3 with 7 because the first bit is same, second bit is changing, so it will be dash, otherwise 1 and 1. Similarly, M3, so it is paired, so it will be ticked. M3 will be paired with M13, checked with M13. So this is same, this is different, different, different. More than one is different, so no pairing will take place. M5 will be compared with M7. So M5 and M7, it is 0, 1 is same, this is different, and this is same. So it is possible. 5 and 7 will be paired. So if we are doing the pairing, it will be 0, then it is 1, and the third bit is changing from the left side, so it will be dash and then 1. Then 5 will be compared with 13, so you can just say first bit is changing, second and third, fourth is not changing, that is only one bit is changing, so 13 will be paired. So 5 will be paired with 13. So the pairing will be like the first bit is changing, otherwise 1 0 1 is there. Next is 5 will be compared 6, yeah, the 6 will be compared with 7. The 6 is compared with the 7, only one bit is changing. 6 is compared with 7, only one bit is changing because 0 0 is same, 1 1 is same, this last bit is changing, so 0 1 1 last bit is changing, so it will be dash. M6 now will be compared with the M13. If we check, one bit is changed to 2 bit change, 3 bit change, 4 bit change, so it will not be paired. Now M9 will be compared with M7, so it is 1 bit change, 2 bit change, so more than 1 is there, so it will not possible. M9 will be compared with M13, so this is same, this is different, this is same, this is same, so yes, it is a possibility. 9 is compared with 13, so this is same, this is different, second bit is different, third and fourth is same. Now M12 will be compared with M7, so this is different, same, different, 2 bit is different, so it will not be paired. M12 and 13, this is same, this is same, this is same, and last bit is changing, so M12 and 13 will be paired. So here it will be like 1 1 is same, 0 is same, last bit is changing, so it will be like this is the group 2 of table 2. So now all possible comparisons have been done, and from here you can just see like tick mark have been done to all of the mean terms. Its meaning is if any of the mean term is left, it will be ticked as star mark, and that star mark indicate, so star mark basically indicate the prime implicant. Prime implicant means it cannot be reduced further, and it will be part of the minimized expression. Okay, so this is the table 2. Now we will be proceeding with table 3. So table 3 will be again similar to that only. So once we are going to do the table 3, again we will be doing the similar process. Comparison between the terms of group 1 will be done with the terms of group 3, group 2, sorry. So group 1 term will be compared with group 2 terms, one by one. So 1 3 will be compared with 3 7. Okay, so for comparison here, it should be like only one bit change should be there. Again, similar to there, only one bit change should be there. So for one bit change, we should be making sure like this dash should be same. So if dash is there, so dash should be matching the same. Only the bits, the digits are there. 0 1 0 1 is there. So this should be changing. So while comparing 1 3 with the terms of group 2, we will be checking where it is dash at the second position from the right side. So here, this is the second position at the right side, and also yes, no other term is there. So only one term is there, like it's 5 7. So you can just compare 1 3 with 5 7. So it is 0, it is 0 here also. It is 1, it is 0, so one bit change. This is dash same. This is 1, this is 1 same. So only one bit change is there at B position. At B position, one bit change is there. So it will be paired. So how the pairing will be done? It will be paired like 1 3 5 7. Okay, and then its digits will be like 0 will be 0. This is 0, and here 1 is there, so it will be dash, and this is already dash, and then 1. So once the pairing is done, so this is being paired with 5 7, not with any other. Okay, so we'll not be taking it out anyone. So this has been done. Next, we will be considering 1 5, and we will be compared with the terms of group 2. So here the dash, you can just look at dash position. So this dash position is at B location. B is having dash, so we will be looking at B position where dash is there. So this is the B position where dash is there, and this is the B position where dash is there. So these two terms can be compared, because all other will not be compared because they are not having the same thing. Because dash should be matching to compare. Okay, so we will be comparing 1 5 with 3 7. So once we compare 1 5 with 3 7, you can say 0 and 0, dash is dash same. This is different. The second bit is different, and here this term and this term is same. So this can be grouped together. Okay. So after grouping together, it is 1 5 3 7. So it is nothing but the 1 5 3 7. So that we have already done it here. It is 0 dash dash 1 will be coming out. So that we have already done. Okay. So only one time we will be writing. No need to write again, but we will be taking it out here because this can be done in the same way, or you can write it down. Once you have the grouping, you can write it down like 1 3 5 7 and 0 dash dash 1. Next, we will be comparing it with this one, 9 and 13. So you can just see it is 1 and this is 0. This is dash, this is 0 1. So only one bit is changing. So we will be comparing it here like 1 5 9 and 13. 9 and 13. So this is grouped with 1 5. So it is a dash dash 0 1. Okay. Next we will be comparing is 1 9. 1 9 is having dash 0 0 1. So this dash is at the A position. So we will be looking at A position, where is the dash. So it is at 5 and 13. So here it is. So 1 9 and 530. 1 9 and 530. This is change. This is same. Three digits are same. Only one digit is changing. So we will be comparing. We will be grouping. So it is coming out to be 1 5 9 13 only. So it is dash dash 0 1 will be coming. So we will be taking it out because it has been compared and it is being paired here. So we will be taking it out. Next, we will be looking at 4 5. So 4 5, for 4 5 it is 0 1 0 dash. So we will be searching for this dash into the next group. So at the last, we are having two different dash at the last digit or at last location. So now we will be comparing it out. So 4 5 is compared with 6 7. So this dash dash, this is 1, it is changing. It is 1, it is 1, it is 0 0. So it is same. So it will be paired 4 5 6 7. 4 5 6 7, it is paired with the 6 7, such that it is coming out to be like 0, and then it is 1 0 1, then dash dash 0 1 and dash dash. Next, we will be comparing with the last one. 4 5 will be compared here. This is dash, this is 0, this is 1, this is 0. So it is also being paired. So 4 5 12 13, it can be paired such that it is coming out to be like dash 1 0 dash after comparing. Okay. Next is we need to compare 4 6. So it is at the second position. There is a uh, dash. So this dash at the second position from the right side. This is the only one. Yes, only one instance is there. So 4 6 will be compared with 5 7. 4 6 is 5 7. So it will be compared and it is going to group together. So 4 6 5 7, instead of that we will be writing in ascending order 4 5 6 7, and its pairing will be like 0 1 dash dash. Okay. Next, we will be looking at 412 is paired with which one. So this dash is available here. So we'll be searching it out. Otherwise, it is not available at anywhere. So it will not. It cannot be compared with other. So we're looking like 412 513. So this is dash. This is one. This is 0, and last bit is only changing. So only one bit is changing. So it will be again pairing it out. So 4 5 12 13. 4 5 12 13. It is dash 1 0 dash. This will be coming out to be dash 0 1. Then this one is changing. So it will be dash. So all possible, yeah, this will be taken together. Yeah. So here you can just see, after all possible combinations of pairing, all terms have been ticked. Means either one time or two times they have been paired. So it has been ticked. It has been ticked in the sense these terms will not be the part of the minimized expression. So here now you can just see 1357 1357. It is same only. So we can, if there is a repetition, we will be writing it only one time. So it is 1357 1357. It is 0 dash dash 1. So it has been done. It has been done. 15913 15913. So 15913. That is dash dash 01. So this has been done. So here 4 6 4 5 6 7. So next is 4 5 6 7. So 4 5 6 7 is 0 1 dash dash. 4 5 6 7 is this, and 4 5 6 7 is this. That has been done. Next is 4 5 12 13. So 4 5 12 13, it is dash 1 0 dash. So these are the four unique terms. You can call it like these are the four unique terms. It cannot be reduced further. If it cannot be reduced further, then we will be making it star. Star in the sense now it is the prime implicate. So prime implicate in the sense after reduction, these will be the terms that will be defining the expression. So what will the expression here? The function f will be, so this position is basically a b c d. So this each term will be indicating one mean term. So what it is about, like it is a is 0, so it is a bar. A is 0 means a bar. BC, so BC is there. If it is dash, we will be neglecting. That means it has been neglected or it has been minimized. So D is 1. That means it is D plus. For this, dash dash is there means A B has been minimized. C is 0, D is 1 means C bar D. C bar D. Next is 4 5 6 7. So 4 5 6 7 is 0 1 dash dash. So dash dash means C and D has been optimized or minimized. So it will be A bar B. From here we can depict like it is B C bar. So this is the reduced expression of the terms that is available into the mean term expression for the function f. Okay, so this is how the reduction is basically done by using the tabular method. So this is called basically the tabular method. Then we will be proceeding with the next example, that will be the product of sum example. So product of sum in the example, in the sense, so suppose any function is there f that is given by the product of some representation a bar b bar c bar plus d bar multiplied by another term, that is a bar plus b bar plus c bar plus d multiplied by a bar plus b bar plus c plus d bar multiplied by a plus b bar plus c bar plus d bar multiplied by a plus b bar plus c bar plus c plus d bar. Okay, so this has been given expression. You can just see this is a canonical form because each of the term or each of the max terms are having all the possible variables. So four variables are there and all possible variables are available in each of the mean term. So it is in canonical form. If it is in canonical form, no need to convert it into canonical form. If it is given in standard form, then we have to convert it into canonical form. That is the first step. After that, we need to do the grouping. So for doing the grouping, we need to identify like what is their max terms. Okay, so it is a bar, b bar, c bar, and d bar. So what it indicates? It indicates 1 1 1 1. This indicate 1 1 1 0. This indicate 1 1 0 1. This indicate 0 1 1 1. And this indicate 0 1 0 1. So this is 15 and this is 12 14, this is 13 and this is 7 and this is 5. So here f can be represented by like the capital pi, that is for product 5 as a max term 5, then 7, then 13, then 14 and 15. This is the f function. Now we have to do the table creation. So we will be doing the table creation. Table 1 we will be creating such that there will be a, b, c, d variables, and then we will be doing the grouping. So how the grouping we will be doing? So grouping will be based on the number of ones. So number of ones. So minimum number of ones is like 2 is there. 2 is the minimum number of one. So based on the grouping, the M5 will be, this is capital M5 because this is max term basically. M5, that is 0 1 0 1, because number of ones 0 and 1 is not there. So 2 is the minimum number of ones. So we will be starting with 2 number of ones. So 0 1 0 1. All others are having more than 2 ones, so it will be a group 1. So now the group 1 will be having only one element, that is M5. So this is group 1. Similarly, for the group 2 will be having more than 2 means 3. 3 is here, 3 is also here, and 3 is also here. So M7, capital M7 is 0 1 1 1. M7. Then M13. So M13, capital M13, that is 1 1 0 1. Capital M14, that is 1 1 1 0. So this will be the group 2. Similarly, the group third 3 will be the M15 only. So M15 will be having all 4 ones. So that is group 3. So all the groups have been done for the table 1. Grouping have been done for table 1. Now we will be creating the table 2. So table 2 will be having the data with respect to the grouping. So we will be doing the grouping. So how the grouping is done with respect to comparison. So we will be again comparing the elements of group 1 with the elements of group 2. So M5 will be compared with M7. So once we are doing the comparison between M5 and M7, you can just see that 0 0 same, 0 0 1 1 same. This is 0 and 1 different. This is same. So only one bit change is there. If only one bit change is there, we will be making the grouping. So 5 and 7 will be grouped together. Okay, and here this third bit or second bit from the right side is changed. So remaining bits will be 0 1, and this is dash and 1. Then M5 will be compared with, and these two are compared and they have been only one bit changing. So grouping has been done, so it will be tick mark. Then M5 will be compared with M13. So you can just see one bit change. This is same, this is same, this is same. So again the grouping is possible because only one bit change is there. So 5 will be paired with 30. So only one bit changes at the MSB bit. Okay, and all others are same 1 0 1. Now M5 will be compared with M14. So it is one change, same, second change. Two changes there. So grouping will not be there. So it is not there. So we can't tick mark M14. So that have been done. Comparison between group 1 element with group 2 has been done. So it will be part of the group 1 of the second table. For second table, this is group 1. Next group will be done by comparing the group 2 elements with group 3 elements. So M7 will be compared with the M15. So once we compare, this first bit is changing. This is same, this is same, this is same. So only one bit is changing. So grouping is possible. So grouping will be done. So M7 will be grouped with 15. So if 7 is grouped with 15, 7 is grouped with 15, what will be the value? It will be dash 1 1 1. Next is M13 will be compared with 15. So it is same, this is different, and this is same. So it is possible. So both are already ticked. So no need to tick further, but pairing will be there. 13 and 15 pairing will be there, and it is 1 1 dash 1. 14. So 14 we will be comparing. So you can just see comparison is done, and only one bit is changing. So it will be tick mark, and 14 will be paired with 15. So it is 1 1 1, and this is dash because it is not changing. So this is the group 2 of table 2. So now we'll be creating the table 3. Okay, so once we are going to create the table 3, in the table 3 again we need to write it down A B C D 4 variables that are available, and we will be comparing now. So group 1 elements will be compared with group 2. This group 1 and 2 are the elements of table 2. So from table 2, the elements of group 1 will be compared with group 2. So 5 7 will be compared with 7 15. So once we do the comparison, so first of all we will doing the comparison for each one, but for simplicity you can just look at it like, if it is dash, whenever there is a dash, that only will be compared with 5 7. So if we talk about here, the dash is at this position, so only this will be compared. So once it is compared, we will be just looking it out, either there is only one bit change or not. So it is 1 and 1 same is there, dash dash same is there, 1 and 1 same is there, 0 and 1 only one bit change is there. If only one bit change is there, so grouping is possible. So if grouping is possible, we will be ticking it out. Okay, so grouping is possible. So 5 7 13 and 15 grouping is possible. So we will be grouping it together, and its bits will be written. So it is, this one is changing, so it will be dash, then 1 dash and 1. Next, it cannot be compared with the other one. Next, we will be comparing with like 5 and 13 with others. So 5 and 13 can be compared with only the first one, 7 and 15. You can just look at it here. This is same, this is same, this is different, and this is same. So 5 13 will be compared with 7 15, and pairing will be done. So 5 7 13 and 15. So it will be dash 1 dash 1. You can just look at it. This 14 and 15 has not been paired with anyone. So because we haven't ticked it. So and now it cannot be paired with anyone. So if it cannot be paired with anyone, then we have to tick mark, we have to star mark, we have to make it a star. So this star indicate like this term will be the prime implicate, means this term will be part of the minimization expression, minimized expression. Okay, now you can just look at it here. In the comparison, this both tables are same, so we can say like these both are part of the minimized expression, or both are same. So only one time if we are writing, that is okay. We need not to write two times. So you can just think of it like instead of writing this, we can write like only one time we can write. It is dash 1 dash 1. So this is a star. That means this is the prime implicate. So now it cannot be further minimized. So the expression for the final minimized expression for function f will be here. From here we will be writing the expression. First of all, it is product of sum. So after minimization, we will be writing in product of sum only. So this is a term. So here a is 1. So if a is 1, it is going to indicate a bar, plus b is 1, so b bar, c is 1, so c bar, and d is dash. So we will be understanding like d has been minimized. Now because it is product of sum, that's why we are writing in product of sum format. So this is the next prime implicate. So it is like this has been optimized. This is c. So it is c bar plus d is 1, so it is d bar. So this is the minimized expression for the given function.